A warm welcome to all delegates and partners. Firstly, I would like to thank you for your interest in wanting to know more about the Singapore Semiconductor Intelligent Manufacturing Framework. Singapore Semiconductor Industry Association, or SSIA, is a trade association representing the semiconductor companies in Singapore. We have more than 160 corporate members, of which most of the multinational companies, or NMC, are in our network today. SSIA is focused on two areas. Firstly, to develop and grow the industry talent pool, and secondly, to strengthen and grow our local ecosystem to better support the industry. As you have heard from the news in recent months, there is a major chip shortage globally, mostly fueled by the spike in demand due to the digitalization trend and emerging technologies such as 5G. And this trend is set to continue through to 2023. Companies in the semiconductor industry is expanding, both in short and long-term investment. Singapore is one of the global semiconductor manufacturing hub, where we supply up to 10% of the global chips. Based on a study made by Boston Consulting Group and SIA late last year, the semiconductor manufacturing is expected to grow even more by another 56% over the next decade. All these trends make it even more important for the industry to adopt advanced manufacturing solutions to maximize productivity. The Semiconductor Intelligent Manufacturing Framework is an important initiative by SSIA. It is not a secret that the semiconductor manufacturing has already adopted advanced automation decades ago as part of our industry continuous culture to drive down costs and drive up productivity. We have adopted semi-standards, for example, and many of these standards may differ from today's mainstream Industry 4.0 standards. It is therefore even more crucial for the semiconductor companies to share details about what the industry's intelligent manufacturing framework is all about to the wider audiences. This framework is a result of close partnership between SSIA, the industry, IHLs, and the government partners. If I may dive a little into this framework, this is an initiative that introduces existing advanced semiconductor manufacturing solutions and at the same time leverages on new Industry 4.0 technologies to further improve manufacturing competency and competitiveness by outlining the architecture of the framework and transformation methods. With all this information that can make an impact onto how our industry operates even more effectively and efficiently, it is only natural that we want to leverage this industry know-how collectively and holistically by devising and eventually sharing an architecture for intelligent manufacturing, and ultimately to help companies transform using this framework. So who is this framework for? You could be a company who is keen to embark on a more intelligent manufacturing journey to improve productivity, or a supplier who needs to develop customer solution in this space, or on a broader note, member of semiconductor, electronics, or any other industry, product and services providers, government agency, or even trade association representatives who are seeking relevant technology solutions, which is why this framework and its potential impact could be much wider and more relevant than we can imagine. Together with the members presenting at this session, as well as those who have registered their interest to be part of our pilot exercise, we are now ready to unveil more about the Intelligent Manufacturing Framework. Of course, if you have more questions about this framework or want to find out how to be involved, do reach out to my team. I will leave your time with the rest of the presenters today and hope you will leave with good insights of this framework. Thank you. Stay safe and healthy.
So good days. I'm Jonathan. I'm honored to present the topic. It's a Singapore Semiconductor Intelligence Manufacturing Framework. All right. So allow me to introduce myself. I'm Jonathan Chang. I'm currently the AVP for Vanguard in charge of corporate planning, industry engineering, IT, and factory automation CIM team. And also I'm in charge the digital transformation program in Vanguard. Myself have worked in semiconductor for 27 years, and I have worked in 8-inch factory, 12-inch factory, and also the 18-inch program. And beside the foundry in TSMC, I also had worked in memory DRAM industry as well. I also work in the Infineon backend operation, assembly and test line as a senior director for factory integration team. I have support the worldwide best semiconductor manufacturing performance. Luckily, I have the chance to work in the very early stage of the 300mm and produce the new baseline for 300mm performance. And I also very honored to have the opportunity to join the 18-inch programs. And recently, I have been in Bangkok. During this huge change of the overall semiconductor supply chain. Within these 2 years, we have managed to continue 8 quarters of growth in revenue and margins. Of course, quite a lot of effort from the intelligence manufacturing, intelligence management. And I have the IT background, so I have several IT certification, including the ITAP, then the project management certification, and of course Microsoft network certification, and so on. And I also have 20 journal and conference paper and several patents for semiconductor supply chain and manufacturing areas. At this moment, I'm this SIMF task. I also am the member of the Taiwan Semi Smart Manufacturing Committee member. And I am also the chairman for IEEE P2671's visual inspection standard task. All right, so I'm glad to have this chance to introduce what is SIMF today. The agenda today I'm going to show to you, actually including the common problem when manufacturing company would like to use Industry 4.0 and what is the know-how to control the key parameter to improve the performance. And I also will take this opportunity to let you know how can the SIMF to help the manufacturing company to improve the manufacturing performance by Industry 4.0 solution. And last but not least, I will show some use case. So the first question is, what is a common problem we have when the manufacturing company would like to do the digital transformation use Industry 4.0? And the roadblock, the first problem always come in is what manufacturing KPI should manufacturing company improve? Before implement any Industry 4.0 solution, manufacturing company need to know what to improve. And in this SIMF, the framework, we provide the manufacturing KPI definition based on the manufacturing theory and also the proven indices in most complicated manufacturing process. And second is, I believe quite a lot of the company have tried to adopt or integrate or implement some Industry 4.0 solution, but a lot of company find the end result might not be as expected. So several problems happen here because Industry 4.0 solution, it might control certain performance item, but not be the company really need urgently. So what we need to do is we have to provide an effective guidance and process to assess manufacturing performance. This process is required. And also the Industry 4.0 solution control, which has been implemented by this company, they control certain parameter, but this parameter might not be the key parameter for the specific performance they want to improve. So in the framework, we also provide the effective guidance and process to define key parameters to improve the performance. And also, Industry 4.0 solution, including many IT technology, including IoT, automation, big data, AI, and so on. And with so many solutions, actually the integration is very tough. So in the framework, we also provide the effective guidance to pick up the right solution, effectively integrate with the manufacturing performance we want to bring together. And although we have the solution, the last problem we always found is some company invest a lot of Industry 4.0 solution, but in the end, it didn't change the company doing the business. So pretty sure it's Industry 4.0 solution is not effectively integrated into the manufacturing operation. So also that will be the focus. SIMF would like to help show some guidance to how to transform. And current, why we can help the overall manufacturing company in Singapore, because we, under the SSIA's initiative, we came from semiconductor manufacturing background, and semiconductor has been one of the most complex manufacturing process with very long cycle time. And if you look at today's, the 5 nanometer, 7 nanometer, the overall cycle time may be up to 3 months, or even some to 4 months to finish the process. And including also the most process step, and they also request very precise measurement and operation. And semiconductor manufacturing has fully leveraged Industry 3.0 capability for the necessary performance management from the last 3 decades, including below capability to enable the competitive manufacturing from the last 30 years. And one part we always can see from semiconductor industry is there is comprehensive automation system in semiconductor company, including the MES system, ERP system, CRM system, APC, shop floor control, EDA, data analysis, and EDA for design automation, and also the equipment automation. So it's very comprehensive. And based on this comprehensive system, there is a huge big data, but might not be integrated seamless, but at least they have a very huge data, including the logistic data and engineering data from the machine, material, main environment, and so on. And also, semiconductor has also developed quite a lot of the auto decision system in logistic decision, including like capacity optimization, wafer start optimization, wafer dispatching, tool PM scheduling, and so on, and also including the engineering decision systems, advanced process control, advanced yield analysis, and so on. So from this huge history, we understand the last manufacturing experience and also the system capability really can help most of the manufacturing company which really need to the digital transformation. So the purpose why we want to have this SIMF in Singapore, and what we want to do is we want to show effective intelligence manufacturing implementation method with this semiconductor know-how to help the manufacturing company in Singapore. And also we show the new novel innovative integration between the manufacturing management and the new Industry 4.0 technology. The effective integration will enable the very fast development of the new manufacturing competency. And also we will use this new framework, standard and integration method to improve overall Singapore semiconductor manufacturing competency, which it was never before, and also establish for solution provider to develop this solution in Singapore. And at the same time, we know the futures will still need to depend on our future talent. So we also cooperate with the academy to provide the future manufacturing management concept and textbook for the talent, and hope we can grab more talent to help enable the future Singapore manufacturing competency. Implement this SIMF will enhance the company in Singapore to have better competitive advantage in high quality, low cost, and also personalized product and high value added service through this life cycle. And this SIMF framework task has been started since February 2020, and led by myself and supported by Global Foundry Jimmy Go, and he's a director for the system team, and also co-sponsored by SSIA and also supported by SP and NYP. And it has been communicated during these 2 years in several events and school by SSIA. And overall contents, the version 1, we including what is manufacturing evolutions from chapter 1 to chapter 4. And also we introduce what is a manufacturing excellence definition and what is a control methodology in the chapter 5 to 6. And we do some comparison between Industry 3.0 and 4.0. And we have some technical architecture to support Industry 4.0 solution. And finally, we give some suggest structure and object database to how to build up the SIMF future solutions. And the last, we will organize, we provide the information how to transform the today's manufacturing organization and operation into the Industry 4.0's enable embedded operations. We are continuing working with the SSIA and also the manufacturing industry in Singapore to help enhance further contents inside. And how does the manufacturing really can leverage Industry 4.0? First, I need to introduce what is manufacturing concept. And based on the manufacturing theory, manufacturing performance rely on the deviation control capability. And this capability actually can be seen in these two items. And first, if the good manufacturing, the intelligence manufacturing, we can know what is a key parameter we can control. So we have two ways to do it, to achieve this capability. One, we learn from others. So SIMF provide the 30 years of semiconductor manufacturing know-how to tell the people what is a key parameter you can control to achieve certain performance improvement. And another way to do it is we could leverage today's modern technology, including more automation, more IoT, more big data, AI, to find out what is a key parameter to control. And second capability is once you know the parameter, you want to control it. So how to control it actually is a nice part for the Industry 4.0 solution, because they can collect the data in real time, and they can also have the prediction models in real time, and also they can make the decision in the real time, and even they can feedback to the production flow in real time. So all this actually is a totally new process flow, we could fully leverage Industry 4.0. And based on this chart below, this is the queuing theory formula, and then you can see the higher deviation, the cycle time and utilization for the high deviation company. Easily in the low utilization, the cycle time will show up very fast. And the stable company, good control company, actually they can still maintain a very low cycle time, very fast cycle time in the high utilization. That is a difference for manufacturing companies' competency. So you understand manufacturing performance depends on the deviation control. This is an example. So manufacturing company normally want to improve the productivity, cycle time, quality, and cost. And when we start to think about the control we want to improve, actually the manufacturing flow consists of man, machine, material, and method. So just purely for this matrix, you can easily understand how does semiconductor for the last 3 decades control this parameter to improve each performance. This is only one example, and we expect more know-how from semiconductors company and also from academy and even from SME together to enrich this table, and then can become the framework for all the Singapore manufacturing company to leverage. And this is an example. So if I want to improve the cycle time, so regarding the main, and normally the main will be the one deviation source to slow down the cycle time. For example, if I didn't follow the dispatching instruction, it becomes a deviation, and maybe I choose the wrong route to occupy the wrong machine. So it will make the cycle time even longer. So also the queue time control. So I will have to look at all the queue time control to understand the transfer times deviation. Some route might be longer, some route is shorter, and then how can I optimize it? And also during the queue time, I also have to look at how does the people respond to each event. Some people can respond very fast, some people can respond much slower. So how to control all this deviation? I will use a dispatching system. I will use a material transfer time control by the transportation control system. I also will look at the better way to monitor the machine material abnormality recovery action response time by human, and I will monitor and improve. So that is one part to improve the cycle time deviation control. So similar case will happen to machine and material and method. So that is the control table, and then I will show. Actually, I just show you how to control the deviation to impact the cycle time and control method. And based on this theory and also the process flow, I'm glad to introduce you what are the key core concepts in the SIMF. So we introduce this object structure. We start with this object chart. We would like to introduce you all the performance improvement. It actually is key for manufacturing company. So we will start this object library with KPI object. So for example, for this first layer KPI object, we will start with cost, either cost, OEE, or quality, or people productivity, or even flexibility, which performance you want to improve. And under this object, we start to define what are the deviation source or parameter you want to control. For example, just now I show you the cycle time. You want to control the main behavior, or you want to control material or machine. So we will start with cycle time and then the main. Then, of course, I have to start to collect data. So for the main, I need to collect the check-in, check-out time, and then the humans working distance and also the location informations. And I have to define what are the database or system I want to use to collect the information from. I will collect in the relation database from MES, or I want to store them in the Hadoop, the big data. This part will be the IT structure below at this level. All the rest are the IT related. So from the manufacturing performance, I will link up to the data source and then also the data storage. Then I will define the big data and AI's layer to provide the prediction. What will be the good way, and then what will be the prediction method I will use. And also when I do the prediction, I also will do the parameter sensitivity analysis to try to validate whether these parameters are key parameters. So the next one will be the decision object. Once I can predict, I can compare my target, then I can make the decision. What are the new priority, or what are the new route I have to provide to the human? All right. So last but not least, this is a system. The beauty of the system is I can calculate what are the confidence index for any decision. It's different from human. Human, when they make a decision, if you ask the human what is the confidence index, maybe we have to think about it. But under this structure, for any decision, we can always, based on the history data and big data analysis, we can provide the confidence index. So this is the examples, some use case. Just now I introduced you, if I want to improve the cycle time, which is very important for semiconductor, if I want to control it, and one part I want to use to control is linearity. Linearity is material deviation in the production flow. So in this chart, you can see if I don't have this SIMF, normally I will start the manufacturing by linear wafer start. But you know, in the production floor, there is always deviation. So manufacturing just do whatever first in, first out, or some limited management dispatching. So in the end, I will, when the wafer is come out from the factory, I will look at the cycle time and also the delivery performance. That's it. So how we can do it better? So with the SIMF in real time, you can see the cycle time information in real time. And also you can start to look at the WIP, material linearity in the production flow, because semiconductor, the cycle time is very long. So if you don't really control the linearity, easily you can see the accumulated WIP in some areas, and some other area you don't have enough material. So to manage this problem, we always have to control these parameters. And also we use the big data and the prediction and dispatching system to predict and do the correction in real time. So with this SIMF, we will show you what is the parameter you can control, and what is the prediction models you can use, and what is the feedback loop you can establish. Then you feedback to it, to the production flow, then you can get much better cycle time. That's what we want to do. So just now I have introduced you for this object structure, and also I pick up the cycle time and linearity. I want to control it. Then I will collect this information from MES system, and I will store in the big data. And later I will develop the neural network to predict. And then I will use the dispatching system to feedback. Then I'll provide the confidence index for this prediction. And I can even predict, if you follow this decision, what will be the next hours, the week linearity. So that's a capability from SIMF to effectively integrate this SIMF to manufacturing and then improve the cycle time. So one of our partner in this SIMF is from this same comes actually is from Mr. Peter's company, and then they provide this structure how to support the big data database and provide the machine learning capability and optimization. Even they provide the simulation prediction result to support, to improve the cycle time in the production flow. So that is a use case we are working with the lease income company. And another use case you can see is introduced and provided by GlobalFoundries with Sixth Sense. So as we know, the year is quality is a very important index. Most of the manufacturing company in semiconductor actually need to focus. Without quality, without good quality, actually all the wafer is meaningless. So if we don't have this good SIMF, today our manufacturing floor, we will do the routine human inspection, and also we will do the human classification for the defect. And in the end, we just spend longer time, and maybe even the human behavior and quality might not be consistent. So with this working between the GlobalFoundries and Sixth Sense, they offer the new integration method to use the SIMF capabilities to link the new way to detect the defect in real time, and also to have better, faster feedback loop to the production flow to improve the yield. So this is another use case. Our task would like to demonstrate how to use SIMF. So come to my last page. The overall SIMF, I want to share with all the audience, ladies and gentlemen. SIMF provide a new framework to enable Singapore manufacturing industry to next level of the manufacturing competency. And SIMF, we would like to provide the novel guidance for the solution provider to develop, follow the same structure, develop an intelligent solution which need by manufacturing industry. So we help manufacturing company, we help the solution provider, and we provide the integrated manufacturing management. How to integrate manufacturing management method and industry 4.0 know together, and also for academy to develop the future talent, and then they can sustain our future Singapore manufacturing competencies. And we have been working for this 1.5 years, and we at the right time we would like to invite together all of you to develop SIMF contents with SSI member together and academy together to this the smart intelligence solution. And I think at the same time, I believe just reading the document might not be so effective. And also this task force, SIMF task force in the SSI, we also would like to provide some of the consultant service to the Singapore manufacturing company to better understand SIMF, and also to learn how to use it effectively. And even without reading the SIMF, we could also help you to solve some of the immediately manufacturing problems. So I think in the end, I just would like to thanks to everyone, and also to really looking forward to have your support. And then in this new generation of the manufacturing era, I would like to share with you, especially for these 2 years, you can see manufacturing industry become more and more critical in the overall supply chain. And definitely it's the right time for Singapore manufacturing industry to leverage the industry 4.0 to have the new way of the integration and new way of the improvement our competency. I think I end of my topic here. Thank you.
Good afternoon, everyone. Welcome to today's panel discussion on transformation with intelligent manufacturing. I'm Julie Koh, Strategic Programs Director from Singapore Semiconductor Industry Association. I'll be the moderator for today's panel discussion. So today with us are industry leaders and technical experts from the semiconductor industry. We have Dr. Jonathan Chang, AVP of Information Technology and Intelligence Management from Vanguard. So Jonathan is also the lead of the Semiconductor Intelligent Manufacturing Framework Task Force. Next, we have Jimmy Goh, Enterprise Architect from Global Foundries. Jimmy has more than 30 years in fab operations experience, and he leads the Global Foundries Industry 4.0 transformation. He is also one of the key contributors of the Semiconductor Intelligent Manufacturing Framework. Also with us is Dr. Peter Landerman. He is the Chief Business Development Officer and co-founder of DSIM Lab, which focus on high-performance simulation-based business analytics and decision support solutions. Last but not least, we have also Ms. Akansha Jawadni, who is the CEO and co-founder of SixSense, a deep technology startup company which develops defect reduction solution with AI. I would like to thank all the panelists and who are either the leads or strong supporting partners of this intelligent manufacturing framework. So to start off, we would like to hear some thoughts from them about this framework. Let's start with Jonathan. Why did you initiate this intelligent manufacturing framework in the first place?
Thanks, Julie. I think it's initiated during the discussion with my mentor, which is Mr. Andrew Chang. He has been the president for Infineon, and at the moment he discussed with me and advised me to identify some critical paths for Singapore manufacturing industry success based on the 30 years semiconductor manufacturing success stories. That triggered me to think about what we have learned from this most complicated manufacturing process in semiconductor, and how can we form the know-how and even better the simple guidance to help Singapore manufacturing industry. I think that is a start for this SIMF.
What about Jimmy? Would you like to share?
So the senior leadership of my company supports such sharing and learning initiatives. The other reason is, of course, I think this is a worthwhile thing to do. Yeah, and like you say, right, Jonathan actually is the main contributor, and most of the credit should go to him. Yeah, and like you say, right, actually, semiconductor manufacturing, besides being expensive, right, is also very complex and challenging. So this framework will provide a reference structure and a common language for intelligent manufacturing projects. Yeah, in fact, there are a few challenges where we encounter when trying to define this framework. Because first, the framework must be generic, applicable to the different problems and solutions in the semicon industry. Yeah, because problems can be, as varied as finding the root cause of a tiny defect on a wafer to improving the overall yield of a process, right, which is made up of a few hundred steps and impact thousands of wafers. Yeah, and solutions can be as varied as machine learning programs written in Python or R, running on on-premise hardware, to an end-to-end machine learning as a service package in the cloud. Yeah, in other words, this framework must be generic and yet useful. Yeah.
Thank you, Jimmy. How about Akansha? What is your thoughts about this intelligent manufacturing framework?
Sure, Julie. Thanks, Jonathan, for the initiation and for Jimmy for sharing right now. We are entering into the fourth industrial revolution, and revolutionizing isn't easy. So having some guided principles and frameworks designed by the experts from the industry is a great way to approach new styles of manufacturing. Such frameworks, I believe, are good for the industry, especially semiconductors, like you all have been sharing, which is so complex, as it helps each company to avoid starting from scratch and reinventing the wheel. It also helps zoom out across the companies and not think of every single matter in isolation and miss some of the most important areas of consideration. I'm building a defect reduction AI company, and it always makes me appreciate the value of avoiding wastage, be it in terms of material or energy and intelligence to build such frameworks, and avoid missing any real issues. Like I shared, not missing any important areas of consideration.
That's really smart manufacturing. What about Peter?
Yes, thank you. Our view is actually very similar. I think it's very important that such a framework gives the manufacturing company the confidence that firstly, the solution provider, such as our company, DSimLab, would actually follow a framework and methodologies that are generally accepted by the industry. And secondly, projects would really be driven by KPI enhancement. So something that ultimately counts rather than just fancy features. And these KPI enhancement would really be the key driver for such a Industry 4.0 project or intelligent manufacturing projects under the Singapore Intelligent Manufacturing Framework. And I think this should help to take away, to mitigate companies' potential concerns or even fears to embark on smart manufacturing projects.
Hearing about smart manufacturing projects, are there examples that you can share or you have experience that illustrate or represent this framework? Since Jimmy works in the manufacturing fab, maybe we'll start with Jimmy.
So just to give one example that I experienced, where I think this framework will be useful. So since the framework starts with a definition of the problem and the KPI, right? So having a correct KPI is important. Example, if our problem is to predict if a wafer is bad, then the correct KPI is to have the lowest false negative and not overall prediction accuracy, because we do not want to have quality escapes. Because since we ask the model to predict if a wafer is bad, right? Negative means the model is saying the wafer is not bad. False means the prediction is wrong. Hence, the wafer is actually bad, but the model says it's good. So this is a quality escape, right? Yeah. Next is cost. So, we are very sensitive to cost. So do we send our big data to the cloud and build models there? Or we purchase on-premise hardware? Yeah, so these are the examples that, I've experienced. The decisions that the project manager has to make or the company has to make.
Would anyone else like to add more examples?
I think.
Let me.
Okay.
Yeah. Let me step in here. Maybe. What examples have you experienced with our customers that would illustrate this framework? I think a good example would be the implementation of the simulation-based WIP forecasting quite some time ago with our customers, where we basically enabled significant KPI enhancement, cycle time reduction by several days, just by synchronizing the preventive maintenance activities in the fab with the material flow. What was actually essential here, very essential here, was the automation. And this is important for the entire chain of data collection, as we call it, is in the framework, data integrity, data transfer, knowledge discovery, processes, the integration of prediction data and actual performance, the gap analysis, etc. Because otherwise it would not be possible to make this kind of, as we call it, auto decision and enable the feedback control in a timely manner. And it is also essential to portray as many domain-specific attributes of these manufacturing operations, so in this case, semiconductor manufacturing, as possible, because otherwise the quality of prediction would suffer and affect the quality of the control decisions to be made.
Yeah, I think I would like to echo to what Peter mentioned. And from the last 30 years in semiconductor manufacturing management, indeed, we continue practice this method and process like Jimmy mentioned. And indeed, the SIMF is based on our experience in semiconductor. So we continue to practice this process every day. And a little bit different from this innovation in this SIMF, what we did is we integrate the KPI we are using today, and also we integrate with nowadays the new simulation and even the prediction and decision capability integrate together with this object structure. And last but not least, we also introduced the confidence index to help all the people to understand, not only to do the prediction, but also to better showing the confidence level of the prediction data. I think whoever want to make the prediction, he also have to build up the confidence level and then to give the prediction for the decisions.
Maybe Ankansha, you would like to share some examples as well?
Sure, Julie. I would like to add to the framework that was extended by all three of them. We are implementing the similar framework for the AI-based defect classification process in the operations line. And such implementations are happening at companies like Global Foundries and Infineon. I think the end-to-end framework, right from starting from understanding the value of the project in terms of the benefits it brings to manufacturing companies and the investments they will have to make to invest to complete this project was estimated. And ultimately, the end goal of making sure that the outputs of AI are actually converted into actionable decisions and understanding with what confidence should we make use of these decisions in the line was very well seen in such project implementations. So I feel like a good schema has been created, which other companies could also follow and have a very easy way and gateway to implement such projects in the line.
Thank you everyone for sharing all the amazing examples that improve the manufacturing efficiency and productivity. Next, what is your advice to companies that are riding the wave of Industry 4.0 transformation? So maybe this time we'll start with Peter.
Okay, what is my advice? I think it's very simple. What we realize in the course of all the projects that we have been doing in this field is that the organization supporting this really needs to be aligned with the systems to be implemented and the underlying data management mechanisms. Because take this example, if an industrial engineering department insists that certain forecasts need to be generated with supplier committed tool performance data rather than realistic actuals from the production floor, then the quality of the associated decisions obviously will suffer. And worse, the KPI performance and eventually the general confidence in smart manufacturing will also suffer as a consequence. And that is, of course, something that we don't want. So this kind of alignment is really, really critical.
It's indeed important for organizations to be aligned on systems before starting implementation. And what about Jimmy? Any advice for the companies?
Actually, semiconductor companies, especially the front-end fabs, right, are already familiar with I 4.0 concepts, and to a certain degree have some of these capabilities already, right? So our equipment, very expensive equipment, already has IoT sensors that enable real-time FTC control. A lot of data has been collected, but so far, in the past, what we've been doing is descriptive analysis. That means trying to find out what happened, and diagnostic analysis. That means explaining why it happened, so-called root cause analysis, which we are very good at. So what's next, right? So next is to capitalize on what the I 4.0 technology brings. Okay, so now we have more sensors to collect the data, even at a faster data rate. So we can do predictive PM for electromechanical systems like pumps and so on, using edge computing, right? Technology. So of course, data stored in the cloud enables factories at different geography to have standard data structures and analytics, right, including machine learning capabilities. And we know, right, machine learning brings predictive, which is trying to explain what will happen, and prescriptive, right, telling us what should we do, right, capabilities. Hence, actually, the next step of this I 4.0 to me is to automatically make decisions and execute them. We are very good at automatically executing things already. So the next step is to automatically make decisions.
Thank you, Jimmy, on your insights. How about Akansha? Any advice?
Yeah, sure. Thanks, Peter, for sharing on the systems part and for Jimmy on capitalizing technology to make decisions. I would love to add on sharing that I think what's also important is to give these technologies a chance to transform your manufacturing and become your competitive advantage. I'm sure the journey is going to be challenging and meaningful at the same time. But we have to also ensure that the big vision and mission is translated to the engineers and managers on the line with the central leadership that is trying to encourage and reward the management and the engineers. It will lead to better results in the shortest amount of time possible. And definitely whatever will get rewarded will get repeated. So the loop will continue and we will have more innovations in the future of manufacturing coming up.
What about Jonathan? What else should company do to be ready for
I think the SIMF tried to let everybody easily and effectively to step on the industry 4.0 to improve the manufacturing performance. So as what all my dear fellows mentioned, the most important is must understand what performance you want to improve. The company might not be the same as a semiconductor. So maybe some of the company just focus on the productivity, some just need to focus on the cycle time. So just understand what you really want. That is the first topic I think all of us suggest. And second, why we provide this object structure actually is also implied. A lot of solution is available globally. Different from before, Industry 4.0 is developed by the whole world. It's not like Industry 3.0, like Jimmy mentioned, only the rich industry can invest. Industry 4.0 is developed everywhere. So my simple advice is don't have to do everything by yourself. Look at outside. A lot of available solutions like cloud, AI models, mobile app, VR, AR. You don't want to develop by yourself. The last but not least is bear in mind, in the Industry 4.0, even the AI prediction capabilities, the most important capability is continue learning. You will continue learning from whatever we cannot catch, and then we can have feedback loop. The brain in the old company can continue to catch the know-how and continue to build it. That's a very important capability. Okay.
Thank you, Jonathan. Very interesting comments. And in fact, that brings us to that next question that is of interest to the wider audience. Your view, is this framework applicable for other industry beyond semiconductor? Anyone who would like to comment?
Maybe I can follow my previous statement. So I suggest all the interested company want to involve and leverage the SIMF. Try to understand what you need. Of course, it depends on the operation need from each different industry. So definitely, when we start to design this SIMF, the main purpose is to help overall semiconductors and even overall Singapore manufacturing industry. So yes, that is our original goal. So I really encourage even like SME and MNC in Singapore support and co-work with us for this SIMF development.
What about the rest? Any sharing?
Yeah, I agree with Jonathan. Yes, the framework is obviously applicable for other industries because manufacturing should always be done in some kind of smart manner, and smart manufacturing should always follow those functional steps as described in the framework. But that doesn't mean that everybody can realize smart manufacturing, all the industries. because the domain expertise is always very essential, absolutely critical. And that's why, for example, in our case, DSimLab, our focus is on semiconductor front end or wafer fabrication, where we have good capability. But we, for example, would not be able to do the same thing in automotive, for example, or precision engineering.
About Akansha and Jimmy?
Yeah, let me add to that. So I think, yeah, it's very well put that we have to focus on the key problems that SMEs or other industries are facing. The priority of problems could be different than semiconductors. The common problems can exist across industries. And one thing to add to that would be also the readiness for adoption. They may not have the way the data collection systems are in place in semiconductors to also become ready today, but that doesn't discourage them from looking forward to be adopting it in the future. So I think learning the key ways in which the semiconductor manufacturing is doing so well, the inspirations could be taken and could be adopted to the key problems, the priority problems that they have in their line. Additionally, I think even the institutes of higher learning could adopt some frameworks like this to demonstrate to the workforce coming next about what are the kind of analysis that industries do typically and what do they need to be good at. So that could also be a value add to a different ecosystem of partners.
Totally agree. Yeah. And maybe before we wrap up today's panel discussion, would like each of you to maybe share a statement, a key takeaway for our participants. Maybe we'll start with Jonathan.
Yeah, I think as what I mentioned, but maybe I would like to come back to recap one statement just now mentioned by Peter and Akansha. Just now we mentioned the different industry have different domain know-how. Actually, that's a beauty. Actually, the reason we want to develop is a common manufacturing intelligence manufacturing framework. And we want to generalize based on the manufacturing theory. And we can assess based on the various industries character. So come back to my last statement, I think within these overall sections, I would like to emphasize again, we would like to use this framework to work with all the Singapore manufacturing industry to come up the really successful framework can help transform Singapore manufacturing competency. Okay.
Thank you. What about Jimmy? What's the key takeaway for the participants?
Yeah, I think I agree with what Jonathan says, right? So like we say, the journey of 1,000 miles begin with a single step. So Jonathan is very kind to lead this small task force and took this first small step. So we sincerely hope that more experts in the industry will come forward to contribute to this vision. Yeah.
What about Peter?
Yeah, what is my key takeaway? You see, I have been hearing a lot about smart manufacturing and Industry 4.0 in the past, but there have also been many instances where I get the feeling that it was more like sounding nice and a lot of buzzwords, but the key thing here, I think, is that ultimately you can talk about smart manufacturing only once you have realized really measurable and sustainable enhancement of critical KPIs, because otherwise it's just, it sounds good, but sounding good is not sufficient, right? What ultimately counts is what it helps you to in terms of enhancing your business performance. I think this is very important.
How will it help the results? What about Akansha?
I think I would like to note here that my learning and knowledge has improved a lot by just having conversations with experts like Peter, Jonathan, and Jimmy and Julie. So I would like to encourage all the engineers like me to come together and contribute to frameworks like this, because with every sharing and learning, the knowledge would quadruple for everyone in the ecosystem. So yeah, I think that has been a great learning for me throughout the whole experience, and would love to encourage all of them as well.
Thank you to all our panelists today. And it has been a wonderful sharing and insights from all of you. Thank you again for joining us today. Before we end today's Transformation with Intelligent Manufacturing Framework session, if you are interested to understand more on this SIMF white paper, please feel free to scan the QR code or visit SSIA webpage to register your interest and download the Intelligent Manufacturing Framework document. Also, if you have any suggestions or comments on the SIMF white paper, please feel free to contact any of the SSIA secretariat, and we will connect you to the discussion. Thank you again for joining us today.